Hey, it's Mr. Lineski, and we are going to look at 2D figures, area and perimeter of what are known as composite figures. But before we do that, let's just take a look at the area and perimeters of two sort of shapes that aren't on your formula sheet, and that is a rhombus and a trapezoid. So for a rhombus, to find the perimeter, perimeter, remember, is adding up all the outside pieces together. So if you recall in a rhombus, all of these are equal to the same thing, so we'll just call it x. One of the other rules of a rhombus is that the diagonals meet perpendicularly, and the diagonals also bisect each other. And so we're told that this measurement right here, if I sort of draw those lines up, that this diagonal is 30 units long, and so half of that would be 15, and so each of these pieces here is 15. We're also told that this diagonal from here to here is 20 units, so half of that is 10. And so now we're kind of working with a little bit of a right triangle here. And so to solve for x, if I kind of just focus my attention here, I'm going to just do Pythagorean Theorem and solve for x. So 10 squared plus 15 squared is equal to x squared. And when I simplify that, I get the square root of 325, which simplifies to about, I'll say approximately 18. And so we can call each of these sides 18. It doesn't come out to be 18 exactly, but it's pretty close. It rounds to it. So each of these are 18. And so perimeter is just adding those all together. So however you are comfortable doing that, you can say 18 plus 18 plus 18 plus 18, or if you know quicker, you can just say 4 times 18. And that gives us 72 units. So remember, perimeter is still just in units, feet, inches, centimeters, whatever. Area is when we go to squared units. So let's talk about area. So the area formula for a rhombus is diagonal 1 times diagonal 2 divided by 2. So we are actually given those measurements. The diagonals here are 30 and 20. And so when I substitute those values in, it's just 30 times 20 divided by 2. 30 times 20 is 600. 600 divided by 2 is 300. And I'll just say units squared. So that would be the area of that rhombus. For this problem here, we have a trapezoid. And so it looks to be an isosceles trapezoid because we have congruent sides here. So perimeter, we can kind of easily do that one first. I'll change colors. Perimeter, we are just adding the outsides. So perimeter equals 4 plus 5 plus 7 plus 3 plus 5. So that would equal 14 feet. Or no, I'm sorry, 24 feet. What am I doing? 24 feet. So that was pretty nice and easy. All the numbers are given to us. For area, the area of a trapezoid uses the formula base 1 plus base 2 divided by 2 times the height. So it's kind of hard to see on the video here, but maybe you can see it on your paper. There's a little dotted line here. That dotted line actually represents the height of the trapezoid. So we wouldn't use 5 to represent the height because it's a slanted line. If you remember the phrase altitude, when we talked about triangles, the altitude was the line that met perpendicularly. And so we sort of have these right angles here. So we know base 1 and base 2. Base 1 we can call 4. Base 2 is this whole thing here, which 3 plus 7 is 10. So this is the start of our equation. However, we need to figure out what the height is. To figure out what the height is, if you notice, we sort of have a mini little right triangle here, and so we can do Pythagorean Theorem. So off to the side, I'll say 3 squared plus h squared equals 5 squared. So when I subtract that, I get h squared equals 16. 25 minus 9. And so h is equal to 4. So the height of this thing is 4. And so I'll replace this h with a 4. And now again, we just sort of simplify this out. 4 plus 10 is 14. 14 divided by 2 is 7. 7 times 4 is equal to 28. So that would be feet squared. So that is the area of the trapezoid. Looking at composite figures. Composite figures are when you either have to add pieces together or subtract pieces because you're removing something. So number 11 is find the area of the shaded region. So what I like to do for these is kind of break it down into its figures. What do we have? So we have a square and we have a circle. And so what we're doing is we're actually removing a circle from a square. So this is when we're going to subtract. We're going to take the area of the square minus the area of the circle. So we're told that the radius is 5. So I'm going to draw the radius here. And that's 5. So this one's actually kind of complicated. We have to know, well, if that radius is 5, that this radius here is also 5. And that radius transfers those 2 radii, becomes the length of the side of the square. So I just drew a diameter, and the diameter is the length of the square. So again, if I drew a radius or a diameter here, that would also be the length of 10. So this side over here is also 10. These are 10, and these are 10. So area of a square is just length times width. So that would be 10 times 10. So the area of the square is 100. And then area of a circle is pi r squared. So we'll do pi times 5 squared, which that simplifies to about 78.5 when I multiply all that together. And so we subtract 100 minus 78.5, and that gives us about 21.5 centimeters squared, because we're talking about area. This is a figure where we have a rectangle with a triangle on top of it. And so what we're going to do is we're going to take the area of the rectangle. So I'll just say rectangle. And we're going to add to it the area of the triangle. So all of these formulas are found on your formula sheet. Area of a rectangle, again, is length times width. So we have 6 times 14. So the area of that rectangle is 84 inches squared. Area of a triangle is 1/2 base times height. So this 8 inches right here is actually representing the height of the triangle. From this point to this point, that's the height of the triangle, or the altitude. So the height there is 8. And then this 10 inches is telling us the length of this base right here. That's 10, so the base is 10. Multiply that by 1/2. And that gives us an area of 40 inches squared. And again, since this triangle is sitting on top of the rectangle, we're going to add these two numbers together, giving us a total area of 124 inches squared. Alright, and then the last figure that we have a rectangle plus a half of a circle. So I'll say half circle. So we need to figure out, again, the area of the rectangle. That's easy. 8 times 5. Length times width. So 40 centimeters squared. And then for area of the circle, or the half circle, we're still going to use pi r squared, but then we have to divide it by 2 because it's a half of a circle. Oh, my bad, we're finding perimeter. Sorry about that. Let me start over. Sorry about that. That was if we were finding area. Perimeter is just what's the length of the outside here. So, we know that this side's 8, this side's 5, so therefore this side has to be 8 as well. So we know our perimeter is going to be 8 plus 5 plus 8. And then we just need to figure out what is this piece right here. for circumference of a circle. So for the circumference of a circle, that is pi d, because we know that the diameter of the circle is 5. And then we're not doing the whole circle, we're doing half of it. So I'm going to do pi d divided by 2. So that would be 5 times pi divided by 2. And when I basically add that to this, that gives me a total circumference of 28.85 centimeters. So remember, in perimeter, the units just stay the same. They don't become squared. All right, sorry about that little mix-up at the end there. Thank you for watching.